Hi guys, we are gonna learn this new section. It's called product and quotient rules. Previously, in last section, we discussed the power rule and some other rules. In that section, we had this problem. So you are given f of x, and then the problem asks whether this is true or false. Find the derivative of f prime, right? So in that particular problem, we say f prime is equal to the derivative of this guy times the derivative of this guy. So is that true or false? The answer was false. It was false because this function is a product of two functions. There's no such rule saying that the derivative of the product equals the product of the derivative. That's actually wrong. Today we are going to introduce this rule, product rule. When you have product of two functions, how do you handle that? The rule actually says it is equal to the derivative of the first one, which is f prime, times the second one, which is g, plus, so this is something you have to be careful, plus the first one, which is f, times the derivative of the second one, which is g prime. So this is how you handle the product. So if you were to apply this to this new function, you're going to treat you have to identify that this function, there are two terms, a product of two terms. You have to apply this rule to find the derivative of this function. You cannot just use your intuition and then think that the derivative of product equals the product of the derivative. That will be wrong. Now for quotient rule, it is a little different. So first of all, again, you always, I have to say, in the years that of my teaching experience, students tend to do this, f prime over g prime. Always, I have seen this all the time. So this will be totally wrong. So make sure that you don't make that mistake. So there are some certain rules that you have to follow, and the rule for this one is the book introduces as this. So call the f as the let's call it high because it's on top, right? And let's call the g as low because it's on the bottom. So how do you find the derivative of quotient high over low? It's gonna be low square in the denominator, and in the numerator will be low d high, which means the derivative of the top one, minus high d low. Okay, so in other words, when you have a function like f over g, then you would do g squared because it's the low one, and then low d high means g times the derivative of the high, which is f prime, minus high d low, which means high is the f, times the d low, which means the derivative of the lower one, so g prime. That's how we apply the quotient rule. So there's a extended power rule in this new section. Previously, we say the power rule is for integer, the n is integer, but now it's actually for any real number. So it's still the same, x to n times x to the n minus 1. And n can be any integer except, so n can be any integer here, yes. So now, let's apply these rules to the following problems, okay? So to the following problems. So let's look at the rule at the same time. We are going to apply that. So the first one, first of all, you identify this is a product of two functions. The first one is v squared, the second one is this guy. So according to the product rule right here, right there on top, so it's going to be, think of this as your f, right? This is as your g, the second function f. I know that we already named this as f, but just think of the first one as your generically as your f, the second one as your g. So it says f prime, which means the derivative of, so when we find the derivative of, I'm sorry, not the dx, but dv, right? So it's going to be dv. So v squared times square root of v minus 1. Okay, when we find that, it will be the derivative of the first one, which is 2v, times the second one, plus the first function times the derivative of the second function. Okay, and how do you find the derivative of square root of v? So here's the hint. Think about square root of v as v to the power 1/2. So now, when you find the derivative of this guy, so let's apply that. You're going to use the power rule 1/2. V to the 1/2 minus 1, right? Which gives you negative 1/2. And minus the derivative of 1 is 0. Okay, so this is how we apply the rule. Let's simplify. So therefore we have 2v times square root of v minus 2v plus, and here this is your v raised to negative 1/2. Okay, and then so therefore v squared, this is 1/2, times v squared times v to the 1/2, which is 3/2. Okay, and this term actually is the same as v to the 3/2. So we can combine these like terms. So it's going to be 5/2 v to the 3/2 minus 2v. So that's the final answer for the first problem. Now I will sometimes have to remind you that there's always more than one way to do a problem. I actually encourage you to try different ways. Once you have accumulated enough experience, sometimes, in other words, through trying different ways, sometimes you can quickly identify which way is better way. So in this particular example, I can actually rewrite the original function by expanding it, right? You just write it out. This is v squared, this is v to the 1/2. So therefore you have v to the 2 plus 1/2 is 5/2 minus v squared, right? So when you find the derivative of this particular function, you're gonna apply power rule twice. The first one is 5/2 v raised to power 5/2 minus 1, which gives you 3/2, minus, and derivative of v squared is just 2v. Do you see that I pretty much just used 2 steps, and previously I have to use 1, 2, and a lot more algebra was involved. So in this particular problem, I probably will go with just the second way. You just use the power rule directly. All right, so that's the first problem. The second problem, let's look at the second problem. It's very clear that you have two functions. This is your first one, this is your second one, right? And the two, or you can consider 2x as your first one. So in this case, what is my f prime? It's the derivative of the first one. The derivative of 2x gives you 2. 2 times the second function, which is e to the x, plus the first function, which is 2x, times the derivative of e to the x, which is itself. So this is it. I don't think that it's really needed to factor out the common factor, but you certainly could to reduce that to one single term, which is this one. Okay, so the next one, certainly my intention was really not to use one as t and the other one is x. Okay, so it is just simply a type error. So I'm gonna say this is actually my x. So when you find the g prime, similarly treat this as your first function, this as your second function. You get 15x to the 4th e to the x, so derivative of the first one times the second function, plus the first function times the derivative of the second function, which is e to the x. So this is the derivative of this one. So we've practiced the product rule on these three problems. Hopefully you are gonna get a little feel comfortable with the applying product rule. Again, try not to one last comment is the derivative for product, we have its own product rule. Derivative of product is not equal to the product of the derivative. I'll make a separate video for the problems that using the quotient rule.